Hello, welcome to today's video. What we're going to do today is solve trig equations using factoring. We've been using solving trig equations for the past few days. Now we're just going to do ones that include factoring. Before we get into factoring with trig equations, let's go back and remind ourselves how to solve these equations when we're not, or when we don't have cosine sign. Here we look at what's in common. There's an x in both of them, so I'll take it out. So inside the parentheses, we divide this by x to get 3x. We divide this by x to get minus 2. Now we can, if we want to check our answer, we just distribute over the parentheses. X times 3x is 3x squared. X times 2 is negative 2x. Now if we have that factored, like we do here, and we set that equal to 0, what we're doing is we're going to say that either x is equal to 0 or 3x minus 2 is equal to 0. So if we add 2 to both sides, so we have 3x equals 2, divide by 3, our two equations, or two values for x is 2/3 and 0. So that's the solution if I have this is equal to 0. There's two answers, 0 and 2/3. All right, now we can do something similar, but now we have an equal sign. So whenever we have an equal sign and we have an x squared and an x, it's best to subtract 8x on both sides. So I'll have 2x squared minus 8x is equal to 0. Now we factor this out. I can factor a 2 and an x out, leaving x minus 4 inside the parentheses. So once we're here, now we can separate this into two equations. Either 2x is equal to 0 or x minus 4 is equal to 0. So now we divide by 2 on both sides and x equals 0, or we add 4 on both sides, or x equals 4. So those are our two equations, or two values for x. Now this is a little bit more complicated. We're factoring 2x squared minus x minus 1. To factor this, there's nothing that factors out of all three. So we're going to factor this trinomial into two binomials. So 2x times x is going to equal 2x squared. To get this last value, the only things we can multiply are 1 and 1. So now we need to figure out a way where we can have negative x be the middle term. The middle term we find by multiplying the first and the last to get 2, multiplying the insides to get 1x. So this is 2x and 1x. In order for us to add those and get a negative x, this would have to be a negative 2x and a positive 1. Now, I have this factored. Now, if I set that equal to 0, if I want to solve that, now each of these equations comes out. So I have 2x plus 1 equals 0, and x minus 1 equals 0. So I subtract 1, divide by 2, and x will be negative 1/2. Over here, I just have to add 1 on both sides. So x will be 1, or x will be negative 1/2. Up until this point in the video, hopefully everything has been reviewed for you. Now we're going to move to something like this. How do we find the solutions for 2 sine squared theta minus sine squared, or sine theta minus 1 equals 0? Notice how this looks awfully similar to 2x squared minus x minus 1 equals 0, which we did on this previous page. So I would factor it just about the same way. But now instead of an x, we're going to have sine. So 2 sine theta plus 1, 2 sine theta minus 1 will give us this trinomial. So now once we get here, we do the same steps as before. We set this equal to 0, and we set that equal to 0. So I have 2 sine theta plus 1 equals 0, and I have 2 sine theta minus 1 equals 0. Oh, but I just realized I made a mistake. That shouldn't be 2. Hopefully you're screaming at the video saying, Mr. Heave, Mr. Heave. Hopefully. Uh, and so this would be just sine of theta minus 1 equals 0. Now what we do is subtract 1 on both sides. So we have 2 sine of theta equals negative 1. Divide by that by 2, and sine of theta equals negative 1/2. And over here we can add 1 to both sides, so sine of theta equals 1. We're at a great spot here. Now we're not done once we get here. We need to find all the values of theta that work where sine of theta equals 1/2. So if I drew out negative 1/2, negative 1 over 2 would happen here, and it would happen here. This is a 30, 60, 90, and across from the 1 is the 30. So this is at 210 and 330. So theta can equal 210 plus 360n, or k, and theta could also be 330 plus 360k. Now, this takes up all of the answers here. Now, over here, sine says sine of theta is equal to 1. Sine of theta equal 1 is right here. That's where the y value is 1, and that's at 90 degrees. So theta equals 90 plus 360k. So these are our general solutions. If I want to find more specific solutions, say if I want to find the values between 0 and 360, those would be 90, 210, and 330. Of course, these are all in degrees. All right, that's one problem. Here's our next problem. Find all the solutions to cosine squared theta minus 2 cosine theta minus 3. To do this, we first need to factor. Cosine theta times cosine theta is going to be cosine squared theta. Now, to equal 3, one number has to be 3 and one has to be 1. Now when I do the outsides, it's going to be 1 cosine theta, 3 cosine theta. To get negative 2 cosine theta, the 3 has to be negative, the 1 has to be positive. Now we separate this up. So we have cosine of theta minus 3 equals 0, and the cosine of theta plus 1 equals 0. Over here we add 3 to both sides. Here we subtract 1 on both sides. And now if you tried to take the inverse cosine of 3, your calculator would say there's an error. The reason is because it's saying the adjacent is 3 times bigger than the hypotenuse, which is not possible. So there are no solutions for this factor. For this factor over here, cosine is at negative 1. That means your x value is negative 1, and that's at 180 degrees. So, and that's the only place. So that would be at 180 plus 360n. So this is our only general equation for this situation. And again, if I wanted to find between 0 and 360, the only answer here is just 180. All right, hopefully you're getting the hang of this a little bit. This one looks a little bit more confusing, but it's similar to one of our examples earlier. If sine squared theta equals 1/2 sine theta, we can subtract 1/2 sine theta on both sides to get sine squared theta minus 1/2 sine theta equals 0. Now if we factor out the sine of theta from both sides, this would be sine of theta. This would just be minus 1/2. Now from here, we set both of these equal to 0. So we have the sine of theta is equal to 0, and the sine of theta minus 1/2 is equal to 0. So where is sine 0? Well, it's going to be at 0, 180, because it's where the y value is 0, and 360. So we could just do 0 plus 180k, I guess, for this one. Or we could do 0 plus 360k and 180 plus 360k. But 0 plus 180k would encompass all the solutions here. If I add 1/2 to both sides, now we have to think about where sine of theta is 1/2. That's here and here. So 30 and 150. So we have two more equations, 30 plus 360k and 150 plus 360k. So those and that are our general solution. If I want to find all the values between 0 and 360, there's 0, 180, 360, and 30 and 150. And there you go. All right, hopefully this is making some sense. Now there's one more problem, and we are all done. All right, looking at this problem, we have to think about what we can take out from both sides of the equation. And it looks like there's a sine of theta and a 2. So if I divide a 2 sine of theta from each side, this would be left with 2. The sine of theta would be gone. Cosine theta. If I take 2 sine of theta out of this one, that would equal 1. Now this is a little confusing for people. Like, why put a 1 here? And the reason is if I distributed this back into the problem, if I don't have a 1 here, this wouldn't be, this wouldn't equal this, because 2 sine of theta times 0 is not 2 sine of theta. We need a 1 here so we can distribute that back in and make that equal. So now if I set this equal to 0, now we have this nice factored form. We can split this both up, and we can say 2 sine of theta is equal to 0, or 2 cosine of theta plus 1 is equal to 0. Over here you divide by 2, and 0 divided by 2 is still 0. Over here you subtract 1 and divide by 2. Cut that up into a couple steps. So I have cosine of theta equals 1/2. Sine of theta equals 0. We figured out on the last page. We can do it again here. We'll be at 0, 180, 360, and so on. So that could be 0 plus 180k. Over here, cosine of theta is negative 1/2. That's these two values, negative 1/2. So that will be a 60-degree angle. So that would be at 120 and 240. So our two values here is 120 plus 360k and 240 plus 360k. So those are our general solutions. If I want to find the value between 0 and 360, again, we have 0, 180, 360, 120, and 240. All right, hopefully that made sense. We're just continuing with what we did before, and now there's a couple problems for you to do on your own. Good luck.